Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our last video we discussed the problems based on method of substitution in integration. And students, in today's video let us learn the concepts based on and problems based on trigonometric identities. So student, in our lower classes we studied what are trigonometric identities. Basically there are three trigonometric identities. The first identity says that sine squared theta plus cos squared theta is equals to 1. With this we can find two more formulas. The first one is sine squared theta is equals to 1 minus cos squared theta, and cos squared theta is equals to 1 minus sine squared theta. The second is 1 plus tan squared theta is equals to secant squared theta, and with this tan square can be written as secant squared theta minus 1. Third is 1 plus cot squared theta is equals to cosecant squared theta. So cot squared theta is equals to cosecant squared theta minus 1. These three are called as the trigonometric identities. Now today we are going to solve problem based on this, as well as we are going to use transformation formulas in today's topic. Transformation formulas. Transformation formulas in the sense we will use product into addition or subtraction form, and subtraction and addition will be converted to multiplication form. So under this, the first formula will be, it is like this: sin x cos y, this is equals to 1 by 2 sin x plus y plus sin x minus y. Then second, cos x cos x sin y I will take. Sin y is equals to half. There is a bracket after half, because half multiplies to both the term. Half into sin x plus y minus sin x minus. Then the third is sin x sin y is equals to minus half cos x plus y minus cos x minus y. And the last is, fourth formula is cos x cos y is equals to half bracket cos x plus y plus cos x minus y. So students, today we are going to use all these formulas. 3 plus 4 formulas. 3 identities and then is 4 formulas. So today whatever the problems we will solve, it is purely based on these formulas. So I hope you remember these formulas. Okay students, now let us solve the problems of integration based on trigonometric identities. Under that, the first problem is find the integral of sin 3x into cos 4x. Very simple problem. Find the integral of sin 3x into cos 4x. And students, one more thing here. In integration, he will never specify a topic in the examination hall. He will simply ask the question in the question paper that find the integral of some function or so and so function. In that case, we should identify a particular question belongs to which topic. For that, we should be good enough in trigonometric formulas. If you are good in trigonometric formulas, we can easily identify, and if you have practiced well, if you have seen our videos with full concentration, definitely you can easily understand the problem. It is related to which topic, and you can easily solve the problems and you will get very good marks. So let us try to solve this problem. Solution: I is equals to integral of sin 3x into cos 4x dx. So student, it is in the form of sin x cos y. It is in the form of sin x cos y, and as I given the formulas, so this will become half, okay, integral is a bracket, sin, this is x and this is our y. 3x is x, 4x is our y. So this will become sin x plus y plus sin x minus y, close the bracket, into dx according to transformation formulas. The next step is very simple, just addition of the angles and subtraction of the angles. I is equals to half I will take outside the integral, so this will become sin 7x plus sin of minus x. 3x minus 4x is minus x. Now in first PC we studied sin of minus x is minus sin x. 1 by 2 integral of sin 7x as it is, no changes. There is a plus here, one negative coming out from this, so plus into minus is minus sin x, close the bracket, dx. Now under the integral we have two terms, let us integrate one by one. Half as it is, bracket, integration of sin ax, a is 7 here, so integration of sin ax is minus cos a, that is 7x divided by 7 minus as it is here, integration of sin x is minus cos, minus into minus is plus cos x plus c. This is the final answer. Cos 2x into cos 4x into cos 6x with respect to dx. There are three factors this time: cos 2x, cos 4x and cos 6x. So in this case what we will do, we will apply the formula for first two factors, keep the third factor as it is. After we simplify this two factor, then again we will multiply those two, this simplification with cos 6x, then we can integrate. So if I am taking the first two factors here, if you want we can take last two factors also, no issues. Any two factor we should take, so I preferred first and second. Now here cos x cos y formula it is, and this says that integral half bracket cos x cos y formula. It says that cos x plus y plus cos x minus y. Sorry, x is 2x minus y. Y is 4x. Close the bracket. Into cos 6x as it is. No changes to this with respect to x. Now I'll take half outside the integral. Half is outside the integral. Integral of, now cos 2 plus 4 is 6x plus cos 2x minus 4x is minus 2x. Close the bracket. Cos 6x dx. Now yes student, cos of minus theta, in our first PC we studied, it is cos theta. Cos doesn't give any negative answer. Cos gives always positive answers. Cos of with any negative angle. So cos of minus theta, always it is cos theta. It is positive. Integral of cos 6x minus, plus it is, no negative here, cos 2x, close it, into cos 6x dx. Now, I'll multiply this cos 6x to these two terms. Then what happened? 1 by 2 integral of cos square 6x plus cos 2x into cos 6x dx. Yes, it is like this. Now student, again we can apply the formula here, and cos square x is having a formula. So what is that formula? So it is 1 plus cos 2x divided by 2, cos square x formula. What is the cos square x formula? 1 plus cos 2x whole divided by 2. This is the formula of cos square x. Now here, in place of x, what do we have? We have 6x. So 6 will multiply to this. If I multiply 6 to this, 6 2s are 12. So this term can be written as 1 by 2 integral of 1 plus cos 2 6 are 12x divided by 2. So here cos square x, the formula will be 1 plus cos 2x divided by 2, and here instead of x, what do we have here? 6x we have 6x. So in place of x, if I write 6x, this 6x gets multiplied by 2. 2 6 are 12. So it is 1 plus cos 12x divided by 2 as it is. Plus, here again we should use the formula. This is, I will take this one term. Okay, dx. Okay, this half. Okay, I will take this half also in multiplication. This half is multiplied to this second term also. So half integral cos x cos y formula here. X is 2x, y is 6x this time. What is the formula? It is again half bracket. Same formula as we applied here. Cos x plus y plus cos x minus y. Close the bracket. Now 1 by 2 I will take outside the integral. Already 1 by 2 exists here. So it is 1 by 4 integral of 1 plus cos 12x dx here. Again 1 by 2 outside here. So it is 1 by 4 integral of cos 2 plus 6 8x plus cos 2x minus 6x. 2x minus 6x is minus 4x. Cos of minus 4x, close the bracket, and into dx. So this will be 1 by 4 integral of 1 plus cos 12x into dx plus 1 by 4 integral of cos 8x as it is, no changes here. Cos of minus theta is minus cos, it is just cos theta. Cos of minus theta is cos theta. So positive term plus as it is cos 4x into dx. Now what is the integral of, let us do the integration of all these terms. Integration of one is, this is 1 by 4 bracket x plus integration of cos 12x is, integration of cos is sine 12x by 12, close the bracket, plus 1 by 4, or easily we can take 1 by 4 common here, this 1 by 4 and this 1 by 4. If I take common, I will get like this. So I remove these brackets. I am continuously I am integrating these 4 terms. I have taken 1 by 4 outside. So here 1 by 4 I wrote. Then cos 8x. What is integration of cos 8x? It is sine 8x by 8 plus cos 4x. Integration is sine 4x by 4 plus c is the answer. Okay students, now let us take the next problem. Find the integral of sine cube x into cos cube x with respect to x. There are two terms here, sin x, two factors, sin x and cos x, both are having cube. So this can be solved by taking like this, sin cube x cos cube can be written as cos square x into cos x. Because I know that if I take sin x is t, I will get its derivative as cos x. So I am trying to apply method of substitution here. And one more thing students, in integration, method of substitution we can apply whenever we want. It is not that method of substitution is just particular one method, so we should use only in that particular problems. No. In integration, wherever we feel that we can apply method of substitution, happily we can apply that method. So that is equals to, again, cos square x can be written as sin cube x into 1 minus sin square x. Cos square x is 1 minus sin square x into cos x dx. Now let us take t is our sin x. If I differentiate t with respect to x, I will get the value of dt. Differentiate t with respect to x. So what do I get? dt by dx is equals to cos x. If I do the cross multiplication, then for me dt is cos x dx. So it means the value of dt is cos x dx that exists here. So wherever cos x dx is there, I can write dt in my integral. So So integral becomes sin is t, t cube into 1 minus t square dt, because cos x dx is dt. Now simple multiplication, integration of t cube into 1 t cube minus t cube into t square is t power 5 dt. What is the integration of t cube? We know that it is t power 4 by 4 minus integration of t power 5 is t power 6 by 6 plus c. At last, definitely we should substitute the value of t. What is the value of t? It is sin x. So I is equals to sin power 4x divided by 4 minus sin power 6x by 6 plus c is the answer. Okay students, now let us take the next problem. Find the integral of 1 minus cos x divided by 1 plus cos x dx. So students, very simple problem here. We will directly apply the identities, formulas of cos 2x, and we have seen that 1 minus cos x is, okay, I will first do the rough work here. We know that cos 2x can be written as 1 minus 2 sine square x. So with that, 2 sine square x can be written as 1 minus cos 2x. But student, I have 1 minus cos x here, but in my formula I want 1 minus cos 2x. Means this 2 I don't want. So what I can do is, I will convert this to half angles. Wherever there is an angle, there I will divide by 2. So what I will get? 2 sine square x can be written as 1 minus cos x. This is my numerator part. So 1 minus cos x can be written as 2 sine square x. Next, like that, what is 1 plus cos x? Let us see here. Again I will use cos 2x formula, but this time I will take the other formula of cos 2x, that is 2 cos square x minus 1. So in that, this minus 1 I will shift towards my left hand side. So that gives 2 cos square x is equals to 1 plus cos 2x, or 1 plus cos 2x is equals to 2 cos square x. Again same problem for me. I have 2 here, but I don't need 2 here. I just need 1 plus cos x, but I got 1 plus cos 2x. The best method is convert it to half angles. Wherever there is an angle here, let us divide by 2. So what I will get? 2 cos square, so it is x by 2 here. 2 cos square x by 2 is equals to 1 plus cos x. So 1 plus cos x, that means my denominator is 2 cos square x by 2, and my numerator 1 minus cos x is 2 sin square x by 2. Let us substitute here. So integral is equals to 2 sin square x by 2 divided by 2 cos square x by 2 dx. 2 and 2 gets cancel here. After cancellation, we know that sin by cos is tan. Both are having square. So this can be written as tan square x by 2 dx. Tan square x by 2 dx. Now student, let us create, don't take x by 2 here, because some students will get confusion what is the integration if it is half angles. To avoid that confusion, let us take x by 2 as t here. Otherwise directly we can integrate, but maximum times as seen, I notice that students will get confused here. So what I will do here is put x by 2 value is t, or t is equal to x by 2. Let us differentiate t with respect to x. So if I differentiate t with respect to x, I will get half, because derivative of x is 1. It means the value of dx is 2 dt. If I do the cross multiplication, 2 dt is equals to dx. Cross multiplication on both sides. So the given integral becomes integral of tan square t into 2 dt. I can take this to outside the integral, 2 times of tan square t dt. Now students, we know that we don't have integration of tan square, so let us convert this to its identity. So this 2 as it is, no changes. Integral tan square theta can be written as secant square t minus 1, or secant square theta minus 1, according to the identity. Now let us integrate these two terms. We know that these two terms are having its integral. So that becomes I is equals to 2, this 2 as it is, integration of secant square t. I will use bracket. It is tan t. Integration of 1 with respect to dt, or with respect to t, is minus t plus c. Let us substitute the value of t here. So that becomes 2 times of, what is t? T is x by 2. That means tan x by 2 minus x by 2 plus c. This is the answer. Integral of cos power 4 2x with respect to x. So student, here 4 can be written as 2 square. The best method of writing 4 is 2 square, or 2 into 2 also we can write, but I will prefer 2 square here. That means my cos power 4 will be cos square 2x whole square dx. Square it is. Now after that, we know what is the formula of cos square x. Just now somewhere we derived. I will take one more time. Cos 2x can be written as 2 cos square x minus 1. Cos 2x can be written as 2 cos square x minus 1. So I will shift minus 1 to this side. So 1 plus cos 2x is equals to 2 cos square x. Now student, here I don't want 2 here, so 1 plus cos 2x whole divided by 2 is equals to cos square x is equal to cos square x. So here I have just cos square x, and its formula is 1 plus cos 2x divided by 2. But in my problem, in my integral, I have cos square 2x. I have cos square 2x. So it means in place of x, I should write 2x now. So if I write x as 2x, then this 2 multiplies to this x. So x is 2x, 2 2s are 4. So totally I will get like this. Integration of 1 plus 2 is multiplied to 2 here. So cos 2 into 2x whole divided by 2 whole square dx. Because this cos square 2x has square, that square out here. So this will become integral of 1 plus 2 2s are 4. It will become cos 4x whole divided by okay, I will take square to the numerator as well as square to the denominator. 2 square is 4 dx. I will take 1 by 4 outside the integral. Now a plus b whole square formula. A is 1, b is cos 4x whole square. So that can be written as 1 square plus cos square 4x plus 2 cos 4x into 1 bracket dx. So inside the bracket, whatever the 3 terms I wrote, it is by the help of a plus b whole square formula. Now in this, again there is a problem here. We cannot directly integrate this. So what I can do here, again I can apply these steps. What this says is, say here, I have cos square x. Now I have here cos square 4x. Means wherever there is a x in this formula, there we should write 4x. The moment I write 4x here, in this 4x gets multiplied by 2. Isn't it? There is a 2 here. So this 2 gets multiplied by 4x. So 4 2s will become 8. So I'll write the direct formula. 1 by 4. Integral of 1 square is 1. Plus, it is 1 plus cos 2 times of 4x whole divided by 2 plus 2 cos 4x into 1 is 2 cos 4x. Close the bracket. Dx. Now students, here 1 by 4 integral of 1 plus, I will split the terms here, 1 by 2 plus cos 8x by 2. 1 by 2 plus 2 4s are 8x divided by 2 plus 2 cos 4x into dx. Now students, here 1 plus half, it is 3 by 2. 1 plus half is 3 by 2. So this will be 1 by 4 integral 3 by 2 plus 1 by 2 times of cos 8x plus 2 times of cos 4x. Close the bracket. Dx. This is the final simplification of cos power 4 2x. After simplification, now we should integrate these 3 terms. Now students, let us integrate these 3 terms. So I will erase this part. So I is equals to, so 1 by 4 as it is multiplies to all the 3 terms. Now integration of 3 by 2 with respect to dx. 3 by 2 is constant, with respect to dx is constant into x. 3 by 2x plus 1 by 2 as it is. Integration of cos 8x is sin 8x divided by 8 plus 2 as it is a coefficient. Integration of cos 4x is sin 4x divided by 4. Close the bracket plus c. Then the final simplification will be 2 1 times, 2 2 times. So 1 by 4, 3 by 2x plus sin 8x, 2 into 8 in the denominator, it is 16, plus 2 1 times 2 2 times gets cancelled here, only 2 is in the denominator, sin 4x by 2 plus c. This is the final answer. If you want, we can multiply this 4 to these 3 denominators, or we can take 2 common from the denominator. So let us take the next problem. Find the integral of sin square x divided by 1 plus cos x dx. Very simple problem it is. So let us apply the identity in the numerator part. We know sin square x can be written as 1 minus cos square x. So I is equals to integral sin square x can be written as 1 minus cos square x divided by denominator same, no changes. Now student, here numerator 1 can be written as 1 square. The moment 1 I wrote as 1 square, then I can read this as 1 square minus cos square x. This is in the form of a square minus b square. And a square minus b square can be written as 1 minus cos x into 1 plus cos x. That is a square minus b square can be written as a minus b, a plus b. This is the identity applied. Is equals to a minus b into a plus b. Denominator is same, no changes. 1 plus cos x, of course dx is there here. Now numerator 1 plus cos x gets cancelled with denominator 1 plus cos x. The only left out thing is integral of 1 minus cos x dx. So its integration is integration of 1 with respect to x is x minus as it is integration of cos is sin x plus c. This is the answer. Take the next problem, student. It is integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha into dx. Now, student, this cos 2 alpha and this cos alpha is constant terms here. Constant. But we can apply any formula for this. So what I will do, I will take the cos 2x formula, and one of the cos 2x formula is like this. It is integral of cos 2x can be written as 2 cos square x minus 1. This is the direct formula of 2 cos square x, cos 2x minus as it is. Same formula for cos 2 alpha. Cos 2 alpha can be written as bracket 2 cos square alpha minus 1. Denominators no changes as it is. Cos x minus cos alpha into dx. So this is equals to integral of 2 cos square x minus 1 minus 2 cos square alpha minus 2 cos square alpha minus into minus plus 1 divided by cos x minus cos alpha into dx. So minus 1 plus 1 gets cancel here. So integration of, I'll take 2 outside the integral here because 2 is common in both the terms. So if I remove 2 outside, then I will get cos square x minus cos square alpha whole divided by cos x minus cos alpha into dx. Now student, numerator I have in a square minus b square form again. Last problem we applied a square minus b square identity. In this problem and in this step we must apply same property or same identity. So numerator can be written as cos x minus cos alpha into cos x, sorry it is x, my plus cos alpha. It is a square minus b square form, a minus b, a plus b. Denominator as it is, no changes, minus cos alpha dx. Now numerator cos x minus cos alpha, denominator cos x minus cos alpha as it is equals to 2 times of integral cos x plus cos alpha into dx. Now integration of cos x with respect to x, this 2 as it is, bracket, it is sin x plus, student, as I said, this alpha is a constant, so whatever is function with alpha, it is also constant. So here we got cos alpha, it is a constant. Integration of constant with respect to x is x into constant, x into cos alpha, close the bracket, plus C is the answer. Now student, the next problem is find the integral of cos x minus sin x divided by 1 plus sin 2x with respect to x. I repeat the question. This time the question is find the integral of cos x minus sin x divided by 1 plus sin 2x with respect to x. Very simple one it is. But in this particular problem, we should give importance to 1. We should give importance to 1. And we know that in trigonometry, the value of 1 is, it is cos square theta plus sin square theta. And sin 2 theta formula we can apply. It is 2 sin theta into cos theta. Let us apply formula only to the denominator, numerator as it is, no changes in the numerator. So I is equals to integral cos x minus sin x whole divided by 1 can be written as cos square x plus sin square x plus sin 2x. The first formula of sin 2x is 2 sin x into cos x, obviously, into dx. So student, if I write the denominator, it is cos square x plus sin square x plus 2 sin x cos x. So this is in the form of a square plus b square plus 2ab, isn't it? So the complete denominator can be written as, numerator is as it is, and the denominator can be written as a plus b whole square, isn't it? Our denominator is cos x plus sin x whole square, because if I expand this, definitely I will get this. So student, here I will take this denominator as t, this denominator as t I will take, because I know that its exact derivative exists in my numerator. Derivative of sin is cos, derivative of cos x is minus sin x. It is exists. So I can apply method of substitution here. So put t is equals to cos x plus sin x. So if we differentiate this, directly I will differentiate, we will get cos x derivative is, first I will minus sin x plus cos x dt by dx it is. Now if I write in proper order and if I cross multiply, I will get dt is equals to cos x I will write first, then minus sin x into dx. So what is the value of dt? The value of dt in this problem is cos x minus sin x into dx. So this is there in our numerator. Therefore our integral becomes dt by t square. So this will be, its integration of 1 by t square is, it is minus 1 by t plus c. How it is integration of 1 by t square is minus 1 by t? We know that d by dx of 1 by x is equals to minus 1 by x square. So if we take the integration here, it is integration of minus 1 by x square dx is 1 by x, because integration is a reverse process of differentiation. So if I integrate minus 1 by x square, definitely I will get 1 by x. Since I don't have negative here, so that negative comes to this. Now what is the value of t at the end? At the end it is minus 1 whole divided by t is cos x plus sin x. Cos x plus sin x plus c. Okay, so let us go to the next problem. Find the integral of tan cube 2x into secant 2x dx. So here tan cube can be written as tan square into tan x. That is, x is 2x here. I is equals to integral of tan cube can be written as tan square 2x into tan 2x into secant 2x. Of course dx is there. Then student, again tan square 2x can be written as secant square 2x minus 1. According to identity, this tan square 2x can be written as secant square 2x minus 1. It is tan 2x into secant 2x dx. In this student, and in this particular term, okay, first what I will do, I will multiply this because anyhow it is multiplied to this. So this will be, after multiplication, secant square 2x into tan 2x into secant square 2x minus again I am multiplying 2 1. What happened to this? Okay, I will take dx. I will completely separate the terms. This secant square 2x gets multiplied to tan 2x into secant 2x dx. Then again one more term is there under integral. It is minus 1. To this minus 1 it should get multiplied again. So minus integral of 1 into tan 2x into secant 2x dx. I hope this is clear to you. There are two terms in the bracket. For both the terms I should multiply tan 2x into secant 2x. Now what I will do, first I will integrate this completely, then I will integrate this. So till that I will keep as it is. Otherwise also I can directly take this secant 2x as t in first integral, then I can directly integrate this. But if I take t is equal to secant 2x, you may get confused here also. So to avoid that confusion, I am first integrating this. Integration of secant 2x into tan 2x into secant 2x dx minus. So integration of tan x into secant x. We know the derivative of secant x is secant x into tan x. So here we have tan x into secant, it is 2x is there. So this becomes secant 2x divided by 2 is the direct integration of this. Plus c I will put later because I did integrate this. So in this integration I will take t as secant 2x only in this integral. This is already integrated, its answer is this. So if I differentiate t with respect to x, dt is equals to 2 secant 2x into tan 2x into dx. Or secant 2x tan 2x dx is dt by 2 is equals to secant 2x tan 2x dx. So in my first integral, wherever I have secant 2x tan 2x dx, there I can write dt by 2. So my integral becomes t square into dt by 2 minus secant 2x by 2. Now student 1 by 2 I will take outside. What is integration of t square? It is t cube by 3 minus secant 2x by 2 plus c. This is the answer. At the end we should substitute the value of t. What is t here? T is secant 2x. So the final answer is secant cube 2x divided by 6 minus secant 2x divided by 2. Only here we should substitute the value of t. Okay, students, let us take the next problem. Very simple problem. And the question is, find the integral of tan power 4x with respect to x. Find the integral of tan power 4x with respect to x. Again, as we did cos power 4 to x, similarly we should do tan power 4 x here. So this is our integral. So student, here tan power 4 to x can be written as tan square x whole square. So it is tan square x whole square. Okay. Or we can write this as tan square x whole square is tan square x into tan square x also. Okay, here I will take like this. Now next is, this is, okay, dx is there, sorry. Any one tan square x I will convert to its identity. So first tan square x as it is. The second tan square x can be written as secant square x minus 1. According to identity, tan square x can be written as secant square x minus 1. Now we will do simple multiplication here. What is the simple multiplication we will get here? Tan square x into secant square x minus tan square x dx after multiplication. Now in this case, student, here again this tan square x doesn't have direct integration. So again I will apply identity here. Only in this particular place I will apply identity. This is as it is, no changes. Integration of tan square x secant square x dx minus integral of, just tan square x can be written as secant square x minus 1 into its dx. Two terms I separated with an identity. I applied identity for this tan square x, and that is secant square x minus 1. Here everything as it is. Now student, this is having direct integration, these two, but this creates some problem. So I will apply method of substitution here, and in that I will take t as tan x, because I know derivative of tan x is secant square x, it is exist here. So put t is equals to tan x in first integral. Second integral as it is, directly will integrate. So differentiate t with respect to x. So derivative of tan x is secant square x dx. So in my first integral, wherever I have secant square x dx, there I can write dt. So the integral becomes integral of t square dt minus, this is as it is, integration of secant square x minus 1 dx. So this is with respect to t and this is with respect to x. Integration of t square with respect to t is t cube by 3 minus secant square integration is tan x minus integration of 1 with respect to x is x plus c. Finally, what is t value? It is t is tan x and it has cube divided by 3 minus bracket tan x minus x plus c is the answer. Okay students, the next question is find the integral of sine cube x plus cos cube x whole divided by sine square x into cos square x dx. Find the integral of sine cube x plus cos cube x divided by sine square x into cos square x. So what we can do here is, numerator there are two terms and denominator we have only one term. In that we have two factors. So let us split this terms or separate this. So integral I is equals to integration of sine cube x divided by sine square x into cos square x dx plus integral of cos cube x divided by sin square x into cos square x dx. Now students, let us cancel this wherever there is a possibility. Sin square x gets cancelled with numerator sin square x. Numerator we have 1 times sin x. Denominator cos square x cancel with numerator cos square x. Numerator we have cos x 1 time. Now this is equals to integration of, left out is sin x in the numerator and cos square x in denominator, plus dx is there, integration of cos x in the numerator divided by sin square x in the denominator. After this, cot x so here there are 2 times of cos x. 1 time of cos x I can involve with sin, so I will get sin by cos is tan x, and 1 time cos x left out in the denominator, that is its reciprocal is 1 by cos is secant x dx, plus here cos x by sin x. 1 time sin x I will take with cos x, so it becomes cot x, and 1 by sin x is cosecant x into dx. We have a direct integration for these 2 terms. Integration of tan x into secant x is, it is secant x, plus integration of cot x into cosecant x is minus, it is plus into minus, minus cosecant x plus c, obviously. This is the answer. Find the integral of cos 2x plus 2 sin square x divided by cos square x with respect to x. Very simple problem. Cos 2x plus 2 sin square x divided by cos square x. Here numerator second term and denominator first term is as it is, no changes. We will apply the formula for cos 2x, and we will apply the first formula of cos 2x here. What is the first formula of, or we can apply the directly third formula of cos 2x. Cos 2x has totally 4 formulas. I will apply the third one here. Or one of the formula of cos 2x says that 1 minus 2 sin square x. This is the formula of cos 2x plus 2 sin square x as it is, no changes, divided by cos square x also as it is, no changes here, into dx. Now student, if you see the numerator, we have totally 3 terms in our numerator. In that 2 terms are same with opposite sign. There is a negative 2 sin square x and here is a positive 2 sin square x. So both will get cancelled. So what is left out in the numerator? It is 1, denominator cos square x. Integration of 1 cos square x dx. What is 1 by cos square? We know that it's secant square x dx. The integration of secant square x is tan x, because derivative of tan x is secant square x. So integration of secant square x is tan x plus c is the answer. Okay, students, now let us take the next problem. Find the integral of 1 divided by sin x into cos cube x dx. Okay, students, here he has given integration of 1 divided by sin x into cos cube x. So, students, to solve this, let us focus on the numerator 1. We know that in trigonometry the value of 1 is sin square theta plus cos square theta, or cos square theta plus sin square theta. Let us apply that. So integral I is equals to integration of 1 can be written as sin square x plus cos square x divided by sin x into cos cube x dx. Now, as in the previous problem, as we did, whenever we have two terms in the numerator, let us separate it. Same thing we did in previous problem. Let us apply the same concept this problem also. I will split the terms, then I will get integration of sin square x divided by sin x into cos cube x plus cos square x divided by sin x into cos cube x dx. Let us try to cancel wherever there is a possibilities. Cos square x and cos x gets cancelled. Sin square x, this is only one time it gets cancelled, not complete. Then here one time gets cancelled. So it is left out in the first integral. It is sin x by cos cube x can be written as cos square x into cos x dx plus integral dx divided by, we have here sin x into cos x. Okay. Now student, here sin by cos is tan. Integration of tan x, 1 by cos square is secant square x dx. Sin by cos is tan x, 1 by cos square x is secant square x, plus here student, according to the sin 2x first formula, this can be written as 2 sin x into cos x. But simply I just need sin x cos x. So sin x cos x can be written as sin 2x whole divided by 2. So this will be dx divided by, sin 2x it is, divided by 2. Now this 2 goes to the multiplies to dx. Here, so here I will take I will take the t as tan x here in the first integral. Put t is equals to tan x in our first integral. Second integral as it is, no changes, we will just simplify it. So what do I get? If I differentiate t with respect to x, the value of dt is secant square x dx. The value of dt is secant square x dx in my first integral. It is exists here. So I is equals to integral of t dt plus integration of 2 dx divided by sine 2x. So student, after here 1 by sine is cosecant. 1 by sine is cosecant. So student, here 1 by sine is cosecant 2x can be written, and integration of t is t square by 2 plus 2 is outside the integral into, as I said, 1 by sine is cosecant 2x dx. Student, we know integration of cosecant x, it is log of mod cosecant x minus cot x. Since 2 is multiplied to x, that will come in denominator. So what is the value of t here? T is tan x. So tan square x divided by 2 plus 2 as it is. 1 by 2 will come from this into 1 by 2. It is integration of cosecant 2x is 1 by 2 log mod cosecant 2x minus cot 2x plus c. This 2 and this 2 gets cancelled. The final answer to the given integral is tan square x divided by 2 plus log mod cosecant 2x minus cot 2x plus c is the answer. Find the integral of 1 divided by cos of x minus a into cos of x minus b dx. So this is very standard problem. So here our intention is to make the numerator also similar to these angles. Whatever the angles are given in our denominator with a trigonometric function cos, let us try to get the numerator also similar to this, but angles must be same. We need same angles. So here what we can do is, if there are two cos x terms, let us multiply and divide sine b minus a. B minus a or a minus b, both is possible, but we should be very careful that we should get same angle in the numerator. So based on that we will do some changes, depends on the problem. What I said, to get the same angles in the numerator also with trigonometric function, here in this particular problem I will multiply and divide sine b minus a. If it is sine and cos, that time we will multiply that time we will multiply cos a minus b. If it is both sine comes here, for that also it is cos a minus b, we will multiply and divide. So since here both are cos, I will multiply and divide sine b minus a. So integral becomes I will take outside the integral, sine b minus a, multiplication is inside the integral, whole divided by cos x minus a into cos x minus b into dx. Now in the numerator angle, that is b minus a, in this bracket I will add and subtract x, because I should get these angles in my numerator. So I am adding and subtracting x only inside the numerator angle. So this is equals to 1 by sine b minus a as it is, integral sine as it is, bracket x is added, minus a is there, this minus a as it is, minus x is subtracted here, x is added here and x is subtracted, and plus b as it is. See, there is a plus b here, close the bracket, divided by cos x minus a into cos x minus b into dx. After this, student, this is, I will call it as first angle. Now in this second, that is minus x and plus b, I will take one negative common. 1 divided by sine of b minus a integral sine bracket x minus a. I will take one minus common from these two terms. Then x is positive, plus b becomes minus b. Whole divided by cos x minus a into cos x minus b into dx. Now in this integral, I got a term in the numerator called sine of a minus b. I have two different angles under sine. So this I can read as sine of a minus b. First angle is represented by capital A, second angle is represented by capital B. So in our first PC, we studied the formula of sine of a minus b. That can be written as so numerator is sine of a cos b minus cos a sin b. This is the formula of sine of a minus b, whole divided by denominator as it is, no changes in the denominator, cos of x minus a into cos of x minus b. Of course dx is there. Now student, under the integral I have two terms in the numerator, only one term in the denominator. Again I can split it. So what do I get if I split? 1 divided by sine of b minus a integral sine x minus a cos x minus b divided by cos x minus a cos x minus b minus cos x minus a sin x minus b whole divided by cos x minus a cos x minus b. Dx is there. Now let us try to cancel wherever there is a possibilities. So in the first integral, cos x minus b in the numerator gets cancelled with cos x minus b in the denominator. Now in this second term, cos x minus a in the numerator and cos x minus a in the denominator gets cancelled. So let us write whatever is left out here. Now student, what is left out in this integral is I is equals to 1 divided by sine of b minus a integral of, in the first term, sine x minus a divided by cos x minus a is left out. So sine by cos is tan x minus a minus, I'll use bracket here, sin x minus a cos x minus, sin x minus b cos x minus b is left out. So it is tan of x minus b is left out into dx. Both are tan term under the integral, and we know that integration of tan is exist, and it has two formulas. First is minus log cos x, and second is plus log secant x. I prefer positive formula here, but negative is also correct. Both are exactly correct formulas, but I take with log. With log of secant I will take 1 by sine of b minus a. So the integration of tan x minus a is bracket log of secant x minus a I will take. Instead of taking minus log cos x minus a, I will take log secant x minus a. This minus as it is. Again integration of tan is log of secant x minus b, close the bracket, plus c. Now inside this bracket there are two log terms with subtraction sign, with negative sign between the two terms. So this I can read as log m minus log n. Log m minus log n. It can be written as log m by n. So 1 divided by sine b minus a is multiplied to log of, I'll take mod here, secant x minus a, that is m, divided by secant x minus b, that is n, log m by n, plus c. This is the answer. Student, this is about integration based on trigonometric identities. If you have doubt, any kind of doubt in this topic, you can put your doubt in comment box. If you are new to this channel, don't forget to subscribe. And to help the other students, keep sharing our videos. Thank you, student.